Hello folks, this is Bryce Gernon here, and today we're going to be taking a look at conservative vector fields. Specifically, we're going to be looking at how to figure out if a vector field is conservative, and we're going to be looking at how to find potential functions for conservative vector fields. For this, we're going to go to textbook section 15.3. We're going to do questions 8 and 10. So starting with question number 8, given the vector field, f of x comma y equals 2xy cubed of I plus 3y squared x squared j. First of all, is this conservative? And second, if it is conservative, how do we find a potential function for it? So let's start by remembering that if there is a potential function, f of x comma y, the gradient of this potential function is going to be equal to this vector field. Now, this is useful because we can remember that the gradient is really equal to the partial derivative with respect to x of f of x, I, plus the partial derivative with respect to y of f. And that means that this is also how we define the vector field f. So this term right here, 2xy cubed, must be f sub x, and this 3y squared x squared must be f sub y. Now, there's a couple different ways to define what we're going to be using here, which is the cross-partial property of conservative vector fields. The way in the textbook does it one way. I'm going to do it a way that helps me remember it, which is that generally f of x, the partial derivative with respect and then to a partial derivative with respect to x and then y of f of x is almost always equal to the partial derivative with respect to y and then x of x comma y, which means if we take the partial derivative with respect to y of this term and the partial derivative with respect to x of this term, then if there is a potential function, then those are going to be equal because they will be these interchangeable second partial derivatives. So let's try it out. 2x y cubed, and we're going to do well, remember this is f sub x, so we're going to do dy. That's going to be equal to 6xy squared. Now we're going to take this up here, 3y squared x squared, which is equal to f sub y, which means we're going to be taking the derivative with respect to x. So 3y squared x squared dx equals 6xy squared. Now, is 6xy squared equal to 6xy squared? Well, yes it is, which means we immediately know that this vector field is conservative. So that's the first half of the problem done. F is conservative. Now we need to find a potential function for it. So what we're going to do is take the integrals of these partial derivatives up here to try to find the original function. So if 2xy cubed is our f sub x, then we're going to want to take the integral with respect to x so that we can try to get the original function. So that's going to be equal to x squared y cubed plus a constant, which we're going to call c1. Then we're going to do, for the second term, integral of 3y squared x squared, and then we're going to do it with respect to y, because again, this is f sub y, and we want to get back up to just f. So this is going to be equal to, conveniently, x squared y cubed plus c2. So this is a very simple problem here. So we're going to have c1, because we want to make these equivalent, because these are both essentially f of x comma y equals both of these, all right? So we just want to find a term that really encompasses it. So c1 equals, in this case, all we have is a constant. We don't need to include anything from down here, so it's just going to be k. And C2, again, you know, these are equivalent, and there's nothing else to add. Like, so if we had x squared y cubed down here, if this was x squared y cubed plus, I don't know, y to the fifth or something, right? Then we do C1 equals k plus y to the fifth so that we can get all those terms included. But in this case, we don't need to do that because the conservative vector field is just very simple to solve here, which, you know, I'll take it, huh? So C2 equals k, and that means our final function, plug in the values for either C1 or C2, f of x comma y equals x squared y cubed plus k, where k is a constant. And that is the answer to number 8. Now let's go on to number 10, which is given the, sorry, just readjust the camera right there. Given the vector field f of x comma y equals e to the 2x sine y of I plus e to the 2x cosine y j, is it conservative? And if it is, what's the potential function? So we are going to do e to the 2x sine y dy. That's going to be equal to e to the 2x cosine y. This one, e to the 2x cosine y dx is going to be equal to 2e to the 2x cosine y. Now, does e to the 2x cosine y equal 2e to the 2x cosine y? It doesn't. And that means we stop right here. The vector field is not conservative. F is not conservative. And that's about it. So yeah, I would recommend, of course, checking out the web work for conservative vector fields if you want to get any more experience with that. Other than that, there are a couple other textbook problems. Honestly, right around 8 and 10, you want to do like problem 9, problem 11 of 15.3. I think those would be really good review problems, probably even better than the web work, so go for those. Yeah, other than that, have a wonderful day and good luck with the final.